The objective of this video is to solve equations using addition and subtraction where the variables are after the constant. In the previous video, we talked about how solving addition and subtraction equations where you had x plus 2 equals 7 or x minus 3 equals 8. The variable always came first and the constant came second. Well, in this one, there are some special problems when the constant comes first. So I want to point that out. We can still work with the opposite operations. It's got to be careful about what operation you're looking at. When I've got 3 plus x equals 7, that can be written as x plus 3. It's still the same thing. Addition is commutative. So I can still do that opposite operation of minus 3 and get x is equal to 4. I don't even have to do the swap. I can do minus 3 from both sides, and I get x is equal to 4. Here, again, this is a very similar problem, only now the net 3 is negative. I can swap that around. Addition is commutative. Although that number is negative, when I swap it around, it becomes x plus negative 3 equals 7. When I go to minus, I get minus a minus 3, which becomes plus 3 on both sides. And that gives me x is equal to 10. I can still work with the opposite operation there. I can still look at it as a plus as the operation, and I'll be fine. However, these two, different story. Because subtraction is not commutative. And you really have to start thinking about the operation in terms of the relation to the variable. This is x plus 3. This is not x minus 5. This is 5 minus x, which is completely different. This time, what you need to do is you need to work on the opposite operation depending on the number in front, the sign in front of the number. Here we have a positive 5, so we're going to have to subtract 5 from both sides. And when we do that, we're going to get negative x is equal to 4. That's not good though, because remember we need to have the x all alone. We got that negative sign on there. To make that positive, I would do the opposite of negative 1 times x and do a negative, divide by the negative 1. Because having a negative x is like saying negative 1 times x. Negative 1 over negative 1 is a positive 1. I'm left with x. Whatever I do to one side, I got to do the same thing to the other. So 4 divided by negative 1 gives me negative 4. And that's my answer. If I had done plus 5 to the other side, I would have ended up with 14 as the answer. Let's see which one's correct. Plug it back in. I have 5 minus 14 equals 9. That's using the answer if I had added 5 to the other side. 5 minus 14 gives me negative 9 equals 9. That's not true. However, 5 minus a minus 4 becomes 5 plus 4, which is 9. So our double check does work for that answer. Don't forget that double check. Plugging it back in to the original equation and simplifying is a very powerful tool. It helps you check to make sure that you've got the right answer. Can't do that in social studies. All right, over here we've got negative 4 minus x equals 8. Now, here I want to do the opposite of subtraction, so I'm going to add 4. The minus sign in front here tells me the opposite operation I want to do. So I'm going to add 4, because negative 4 plus 4 becomes 0, which drops out. And I'll be left with negative x on this side of the equal sign. Whenever I do this side, I have to do the same thing over here. So I add 4 there, and I get 12. Remember, I've got to change the negative over, so I'm going to divide by negative 1, and I get x is equal to negative 12. Double check it. Negative 4 minus a minus 12 should be equal to 8. Minus a minus 12 becomes plus 12. Negative 4 plus 12 is 12 minus 4, which is 8. It does double check. Now remember, in order to learn math, you need to do math. So I want you to try these 4 problems by pausing the video, working them out, and I'll go over them in a moment. So pause the video now. And welcome back. Let's go over these problems. The first one here. Again, we're going to do the opposite of the plus 4, so we're going to minus 4 from both sides. That gives me negative x is equal to negative 4. Negative 8 minus negative 4 becomes negative 12. Combining 2 negatives, you're going to end up with a negative. Negative x equals negative 12. Divide by negative 1, and I get x is equal to positive 12. And that's my answer on that one. Here, going over number 2. The sign in front of the 2 is negative, so I'm going to add 2 to both sides of that equal sign there. That gives me negative z is equal to 6. I divide by the negative 1, and I get positive z is equal to negative 6. And that's my final answer there. Over here, the sign in front of the 3 is positive, so I minus 3 from both sides of that equal sign there. That gives me negative y equals 17 minus 3 is 14. I divide by negative 1. That gives me y is equal to negative 14. Over here, the sign in front of the 3 is negative, so I'm going to add 3 to both sides. And I get a is equal to 10. And that's my final answer there. If I had subtracted 3, I would have ended up with 4, which is not the right answer. Negative 3 plus 10 equals 7. Negative 3 plus 4 does not give you 7. All right, hopefully, you now can work around that problem with the variable coming second instead of first in addition and subtraction problems. And I'll see you again next time.